Okay, this is exam 3, problem 14, but with a binomial. Because that, I suppose, would be a reasonable thing to go with. It's just, I think, a lot harder. So, A, you might go with binomial because it's counting. And so that may work. It's a nice discrete distribution. And so then in B, when we try to do our maximum likelihood, well, for any given value, remember our PDF, P of some given X is N choose X, P to the X, 1 minus P to the N minus X. Like that, and so for we had x equals 0, 1, 2, and 3, and different numbers for each of those. So we would multiply these things together, and so we would have our likelihood function of, in this case though, you see it's N and P. Okay, so it's two variables, and so we would have our N choose 0, P to the 0, 1 minus P to the N, and that whole thing was raised to the 59. And then we had N choose 1, P to the 1, 1 minus P to the N minus 1. And there were 27 ones. Keep going here. We got N choose 2, P squared, 1 minus P to the N minus 2. And there were 9 of those, and then 1 of the 3s. So we have P to the 3, 1 minus P to the N minus 3. Okay, so that looks pretty bad, but we can simplify that a little bit. N choose 0 is 1, P to the 0 is 1. So we just have 1 minus P to the 59N to start with there. Then we have N times P times 1 minus P to the N minus 1, all to the 27th. Then we have our N choose 2, so that's N times N minus 1 over 2, P squared, 1 minus P to the N minus 2, and that was all to the 9th, and then we have our last term times N choose 3, so that's N times N minus 1 times N minus 2 all over 6, P cubed, 1 minus P to the N minus 3, and that was just one of them, so it's to the first power. Okay, so we have all that. Now, I multiplied this, I took the logarithm and wrote everything out. I'm going to go with just what I simplified to here. I ended up with 37. Oh, if I take the log of that, so it's the log of L. I got 37 natural log of N plus 10 natural log of N minus 1 plus natural log of N minus 2 Then I got a big long term. Well, I'll do plus, let's see, 37. What do I want next? I'm looking at my stuff here. So, I can put in here 48 natural log of p. So I've got that. I got my log 2. So then just 96n minus 48 natural log of 1 minus p. And then a couple of constant terms, minus 9 log 2 and minus log 6. So I believe that's what you get when you take the log and simplify everything. You get that. So now if we take the derivative with respect to p, okay, so that's the first thing I want to do. I'm going to take the derivative, so the partial of the log of L with respect to p. And so, these first three terms, this one, nothing there. But then I get 48 over p, and then minus 96n minus 48 over 1 minus p, because I get the 1 minus p, but then the chain rule says I get a -1. And so, and then the constants, and so that equals 0. What's nice about that is when you get common denominator here, or just multiply through by p times 1 minus p, you see you end up with 48 minus 48p, and then minus 96np, and then plus 48p. Oh, so that's convenient. We get rid of that, equals 0. And so we get a familiar thing that n times p, what we would have as our average, or our expected value, is just 48 over 96, or 1/2. Okay, so that's a good sign that, I think things are going correctly here. I need to go to a new sheet. Okay, so that was the partial with respect to p. Now, if I do the partial of the natural log of L with respect to n, I get 37 over n plus 10 over n minus 1 plus 1 over n minus 2 plus 96 natural log of 1 minus p equals 0. So let me scroll back up here a little bit. So here is the log of n. So you see that first term, 37 over n, and then 10 over n minus 1 for that derivative, 1 over n minus 2. And then this 48 log p is just 0 because there's no n in there. And I just have this 96n here. So the derivative of that's 96, but it's multiplied by that natural log there. So we get that. And, well, again, multiplying through by all the stuff in the denominators, what we have is that 37 times n minus 1 times n minus 2 plus 10n times n minus 2 plus n times n minus 1, and then plus 96n times n minus 1 times n minus 2 times natural log of 1 minus p is equal to 0. Multiply all that stuff out and put things together, and I believe we get 48n squared minus 133n plus 74 plus then 96n cubed minus 288n squared plus 192. Really feel like I'm missing some n there or something. Let's see. Let me put it on pause a second. Look at my work here. Yeah, I dropped an n on there, so I get 192n. Then all all times natural log of 2n minus 1 minus log of 2n equals 0. Okay, and so then there's no way to solve this other than numerically. And so that's what I did. I went to decimals and I No, it didn't change. No, but I can go in here and fix this to be 8. And 1 over 16 to get NP equal a half. And it actually, it doesn't match up with here we go. The Poisson up here was, with 0.5 that we did earlier in an earlier video. If I hit that, that's in there somewhere. Poisson is there. And then the binomial is here. Let's see, can probably go like that and see them better. So again, there's the binomial is the blue underneath the orange. Orange is the actual data. So it looks pretty good. And if I go with red, you really can't see it come up. And so the red, again, is very similar. But the numbers, if you look at them over in the left-hand side here, the numbers are a little bit different. But at any rate, yeah, that that ends up working quite well. I will not say for sure I didn't have some other error. So like in some transposition, I dropped the n off the 192. Back here, let's see, get back to this. Yeah, I dropped that n off the 192 there. And so that is why it had 105 and 1 over 210. But it kind of all fit about the same. So it seems like it's a pretty flat maximum up there. So probably it appears the most important part was just using NP equal a half. But as long as all my simplification and multiplication was okay on taking these derivatives, then, it does look like we would use something like n equal 8 and p equal 1 over 16 as our maximum likelihood estimators. And so we would get that, and as you saw, we had the plots there, and so I think, let's see, now I can't even remember what the part C was, so I'll have to go looking. So sorry about that. I didn't have that pulled up. I just knew what part B was. So let's see, what the heck was part C? Oh, the 20 hours. So at that point, then it works exactly the same. Just that, we would need to, with this binomial, compute the probability of x equals 0 and raise that to the 20th. And so this is part C, and then plus 20 choose 1 probability that x equals 0 to the 19th, and times probability that x equals 1, and determine what those are. Okay, so I'd have to go back here, all right, and we just use this for each of those. So all right, for probability x equals 0, we just have our n choose 0, and p to the 0, and then 1 minus p to the 20th. And then here, plus 20 choose 1. Again, this is just 1 minus p, so we get 1 minus p to the 19th. And then probability x equals 1 is also 20 choose 1. That's interesting. And then it'll be p, and then 1 minus p to the 19th. So actually, that's probably worth checking out. I hadn't tried that, but let's see. So this is 1 minus 1 over 16 to the 20th plus, and it looks like we get 20 squared here, so 20 squared times 1 over 16 for that p there. And then we get 1 minus 1 over 16 to the 38th. So I'm going to have to check that out and see what we get here. So I better pause it because that'll take me a while to do that. Okay, I had to back up because I got mixed up with this. So this is what we know we have to do, because you either had 20 that went without a problem, or you only had exactly one that went without a problem. So this is what we did in the Poisson case, but then I messed this up because I didn't do p of x equals 0 correctly. N is 8, so this is 8 choose 0, p to the 0, or 1/16, and then 1 minus p to the 8th, but then that is all to the 20th. And so that reduces to 15 over 16 to the 160. Okay, and then plus, and here we have our 20. Now, again, we've got our x equals 0, so that, as we saw back here, that's just going to be 1 minus p to the 8th, and then all to the 19th, so that'll be 8 times 19, which, so as we put that down here, that's going to be a 20 and a 15 over 16 to the 152. And then we have the probability x equals 1, and that is 8 choose 1 times p times 1 minus p to the 7th. Okay, and so we have here 15 over 16 to the 160, and I have calculated that. That's 0.00 zeros, I guess. 327, and we'll toss in a 6 there. And then up here, this is plus, so we've got an 8 and a 20, so that's 160. But p is 1/16, so that's 160 over 16, so that's just 10. And then we have our 15 over 16 to the 159. Okay, and so that's, I gotta look that one up. I don't have that one. Let's see here. We got my 15, 16, and a 10. Let's see, so I've got 10 and then 15. Okay, so I believe this is 0.000349 5. Okay, so if we add those two things together, we end up with a 0.0003, and then 8, 2, I think, as I'm looking at this, 2 and 6. So we'll call it 3. So I believe we end up with that. I do not remember what we ended up with the Poisson, but it would have been something close because the basic probabilities are pretty similar. And so, yeah, I don't know if I have that in my stuff here anywhere. Let's see. No, I don't see it. So I'd have to go back and look at the other video or other work or whatever to see that. But anyway, you know, this part I'm very confident about what we're supposed to do. Once I realized I was mixing up my ends and so forth, I think I got that just fine. And it looks like we've got our correct answer here. But definitely, you know, working with 2 parameters, n and p, and the fact that we ended up with this, you know, highly nonlinear sort of situation up here, definitely made working with the binomial much harder. But the bottom line is, it did appear, because of my mistake, I was able to, you know, of dropping that n back here. It seems relatively flat, so it looks like, you know, the key is to get n times p correct, and as long as you get n times p correct, you're probably going to be pretty close. You know, you may not be exactly at the maximum likelihood estimator, but your calculations look like they might not be too far off. So that's kind of a nice thing to learn. But at any rate, it looks like we wanted 8 and 1/16, and when we do that, we get our answer here for C of 0.0038. Okay, long enough on that.